Hello friends, last class I discussed about the Quinn-McCluskey method. So it is a little bit, it is one kind of the tabular method for determining the essential prime implicant. First you have to calculate the prime implicant by using some tabular methods. And if you remember, the last step I used one kind of the chart. Okay, from the chart we can, you can put the prime implicants and all the mean terms which are available for my function. And if we you can calculate the essential prime implicant from the chart, right? So how can you calculate the essential prime implicant? So I will tell this process again, how we can calculate the essential prime implicant. So there is a different two different ways to calculate the essential prime implicant after calculating the prime implicant from the Quick-McCluskey method. Okay, so the one procedure is finding the cross, and you have to put a straight line, to mark a straight line, to draw a straight line, and by this you can calculate the essential prime implicant. So sometimes for this case, if your chart, the last chart, the chart is not too much simple, then you have to use the other method to calculate the essential prime implicant. For calculating the prime implicant, same process, okay, Quick-McCluskey method. But for calculating the essential prime implicant, there is one method which followed by the Quick-McCluskey method. Okay, so this is the Patrick method. So today I will discuss Patrick method. After that, I will discuss one more method. Okay, right? So Patrick method. So first, for this method, again the Quick-McCluskey method is also required. Okay, so here I am writing the expression. Okay. So, what if you remember, first procedure is I have to write all the midterms based on the number of words in midterms. So, first I am writing all the midterms. Without seeing number of one, I am writing all the midterms. The four variables means all the binary term I am writing in the form of the four variables. 009, 81. This one is 11. So, this one is 11. 11 is 1, 1, 1. Okay. And then 30, 1, 1, 0, 1. 15 is 1, 1, 1, 1. Okay. Now next step is that I have to write all the I have to divide all the minors based on the number of ones. Now you can see there is no single ones, right? So first is the group 0. In group 0, I will check how many two ones are there. Okay, how many two ones are there in group 2? Because you can see in this midterm there is any midterm which has 0, 1. Okay, and there is no element which has only the single one, right? So now I'm counting the 5. In 5, how can you can see that two number of ones are there, right? So that 5 I am writing in a group 0 and 5, 0, 1, 0, 1. So I will check any more two ones are there or not in any mean terms. 9. Okay. Next, group 1. In group 1, I will check how many meters are there which has 3 ones. Okay. So first is M7. Okay. M9, this over M7. Next is M11. M13 also. Next, in group 2, 4 number of ones only. There is only one meter which has 4 number of ones. Okay. Now the third step, I have to compare adjacent groups. Okay, and matching pair I have to find. How can I find? If there is only single bit change, so that will be the matching pair, right? So here I am comparing first M7 with these three, and after that I will compare M9 with these three. Okay, because the group 0 and group 1, this should be compared, right? So first I am checking M0 is matching with any three terms or not, right? So here you can see If you compare M5 and M7, 0, 0 same, 1, 1 same. This is change and these are same. So M0 and sorry M5 and M7 both are matched. M5, M7. So it will be same. First bit same, second bit also same. Third bit change. Here it is 0, here it is 1. So you have to put a dash mark. So now in the fourth bit you can see both these are also same. Right? Now I am coming to M7 with M11. So it is changed 0, 1. Here it is 0, here it is 1. 1, 0, 0, 1. Okay. So you cannot compare M5 with the M7. Our first three bits are changed. Okay. Now M5 with the M13. Okay. So it is 0, 1, 1, 1, 0, 0, 1, 1. Okay. So M5 is matched with M13. It is dash. Here it is 0, here it is 1 dash. Now rest are same. 1, 0, 1. 1, 0, 1. Okay. So after put, if any main term is matched, then I have to put a tick mark here. Okay. Now in the same group, I am comparing M9 with all these three terms. Okay. M9. So M9, this different, this is different, this is different, this is also, this is same. So you cannot compare. Matched. So now M9 with M11. Same, same, different and same. Okay. So M9 is matched with M11. Okay. M9 is matched with M11. And it is 1. Okay. 1 it is 0. 1, 0, dash and 1. Okay. Now M9 with M13. So 1, 1 same, 0, 1 different, 0, 0 same, 1, 1 also same. So M9 also compare with M13. Okay, 1, 1 same, 0, 1 dash. Okay, 0, 1 dash, 0, 0 same, and 1, 1 same. Okay, right? So this is the first one. Now come to the second group. Okay, in second group I have to compare these three terms with this one. Okay, so the group 1 should be matched to compare with group 2. Here I am just checking all these three. Will check with the M15. So first I will check with M5 and I will compare between M5, M7 and M15. So here 0, 1 different. All three are same. So M7 is compared with M15. Okay, first bit is different dash and all three bits are same. Okay, now M11, M15. Here it is same, it is different and both are same. So it is also compare. 1 dash dash here on 1. This is M11 and 15. Okay, now M13, M15. Here also these two are same, this is only different. It is also compare M13 and 15. Okay, 1, 1, 1, 1 dash 1. Okay, right? So next step is again this should be compared with this one. Okay, in the next table. So here I am writing in G0 double dash. Okay, here I'll compare these four terms with these four terms. Okay, consecutively. So here first I'll compare this M5 and M7 with this all these terms. Okay, right? So comparing this one. So how can check, right? So this is little bit difficult to compare this group with this group. So I'll check compare with this dash mark. Okay. Yeah, so here you can see in the third position dash is there. Okay. Any term is there in this group where the dash is present in the third position? Yes, this one. Okay. This should be compared with this one. Okay. Anyway, if you compare this with other two, it will not match. Okay. So if I suppose this should be matched with this one. Okay, now this is remain same. This is also remain same. This is remain same. This is changed. Okay, so now this M5, M7 is compared with that one. Okay, so here it is M5, M7, M13, M15. What is the term? First bit is different. Okay, dash. All three bits are same. 1 dash 1. Okay. Now come to this one. So in this one I can see the dash is in first position. I will see in the next group where my dash position is located. Okay. Here my dash position is located. I suppose this should be matched with this one. Okay. So here I am saying this dash is remain same, this is same, this is different, and this is remain same. So it is also matched with this one. Okay. So here it is M5, M13, M7, M50. Okay. So dash, this is 1, again dash, this is 1. Okay. Third bit is different, all other bits are same. First bit, So now next group. Okay, next I will compare this with this, all the three. Okay, here again I can see the third position dash is there, right? So where in then this group the dash is there, the third position here. Okay, so again this is compared with this one. Okay, so it is M9, M11 with this one. Okay, M13, M15. Okay, so 1, 1. 0, 1 here. We have to put dash. Again dash, dash. Then 1, 1. Okay. So now come to this one. So for that I have to check this with this one, because here also second position dash is there. Here also in second position dash is there. Okay. This should be matched. And 9 and 11. Okay. So if you write here 1, M9, M11, M11, M15. Okay. So here it is 1, 1. It is dash, dash. Here 0, it is 1. It will be dash again. Again it is 1, 1. Okay. Right. So here it is, all are in same group. Okay. You cannot compare this with the other group. Okay. This is the last step. Right. Now we can see here. So these two positions are same. Dash 1, dash 1. So I can remove one position. Okay. I can remove one group. Okay. One terms. Here also you can see these and these both are same. Here also I can remove one terms. Okay. So I have only two prime implicants. This one and this one. What are these prime implicants? I am writing. Okay. Right. This is one prime implicant is contain M5, M7, M13, M50. Okay. First prime implicant. So this is means, so only these two bit are same. This is dash. Dash I cannot include in prime implicant. So it is suppose W, X, Y, Z. It will be X, Z. Second prime implicant is this one. Okay. So because these are same, we can remove this one. We can remove this one. Here it is M9, M11, M13, M15. Okay. So here you can see these two are dashes. Okay, I cannot include these two terms. Okay. Now it is 1, 1. WZ. Okay, these two are my prime implicants. Okay. Now I will draw chart. Okay, chart I will draw. Okay, and from chart also I can find which is the essential prime implicant. And by using the chart, we can use the different method for calculating the essential prime implicant. That is predictive method. Okay. So in prime chart, I will put prime implicants in left hand side. Okay. First is the M5, M7, M13, M15. Second is M9, M11, M13, M15. Okay. Here I am putting all the min terms. Okay. How many min terms? Suppose 5, 7, 9, 11, 13, 15. Okay. Now, so here, so I am comparing this mean term with this mean term and putting cross M5, M7, M7 here, M7 here, M13 here, M15 here. Okay. Now from here, M9, M9 here, cross. Okay. If this mean term is matched with this one, then I am putting cross mark. M11, M13, M14. After that, if you want to calculate essential prime numbers by observing this chart, how can you calculate? If you remember, first I will check vertically any single cross are there or not. You can see vertically here is a single cross, here, here and here. Okay. After that, wherever I found the single cross, I have to consider that single cross, and horizontally I will draw a straight line. Horizontally I will draw a straight line. Whatever cross are covered by this straight line, I am just marking. Okay. So this straight line covers this 5, 7, 13, 15. Now again here you can see single cross. I have to draw a straight line horizontally. Okay, whatever mean term, whatever cross are covered, that I am putting tick mark. Okay, here. So now you can see. So here you can see the horizontal line. This corresponds to essential prime implicant. So here two prime implicant. I can see in two prime implicant all the. I have drawn the horizontal line. No more prime implicants are there where my horizontal line is not there. Okay, so that means here only two prime implicants are there, and two prime implicants are covered by the horizontal lines, two horizontal lines. So both my essential prime implicant, both are my essential prime implicant. Okay, so that means what will be the my f will be xz plus yz. But sometimes by observing this chart I cannot calculate the essential, I cannot use this process. Okay, single cross, then put and circle, then horizontal line. Why? If any chart, if I see, so no single cross is there. If you see from the vertically, no single cross is there, then how can you calculate which is my essential prime implicant? So I can calculate by doing something, but that is difficult. Okay. So what I told, so if I see in a chart no single x is there, if you see from the vertical side no x is there, then I cannot calculate easily which is my essential prime implicant. I cannot use this procedure and circle and draw the horizontal line. Okay, so for that I have to use the Patrick method for finding the essential prime implicant. After this fine, first I am putting this mean term and this mean term in chart, it's fine. After that, with the help of the chart, I have to write one more formula for calculating the essential prime implicant. Okay, for calculating the essential prime implicant. So what is this procedure? Okay, so this I am considering as a pi. First pi I am considering as a, second pi I am considering as a b. Now one formula is there. Okay, in formula there is one formula for calculating the essential prime implicant and final expression, because in final expression only essential prime implicants are should be this should be included. Okay. Now here it is written as a, here it is written as a b. Okay, now here I come to this one. So in a, okay, so vertically I have to include all the x. Okay, so suppose I am including this x. Okay, vertically. Okay, so this is in which position? Eighth row. This x is in eighth row. Okay, so a. Now I am coming to here. Okay, so vertically if I include one more x, I have to put a dot mark. Okay, so here I am writing this x. So this x is again in a. This I mean. Now come to next vertical column. Okay, so I am doing column wise. Okay, next I am come to next vertical column. In next vertical column I can see one x, but this x is in b row. Okay, so I am including one column dot. So then b. Again I can see this x is in b. Okay, and adding one column then b. Okay, if I'm doing add next column then b. In next column I can see two rows are there. Okay, one x in a, one x in b. So if we add a row, then you have to put a plus sign. Okay, So this x is in A plus I want to include one row. Okay, this x is in B row. Okay, vertically by column into column into column. If we're adding column, dot sign. Okay, if we're adding row, then vertical sign. Okay, which value should be in part in that column, the column, the position that is in which row. Okay, row number I am writing here. Okay, these are my row number. Okay, here now the last also. So this my last column x is in 8th row and this x is in bth row. Right, again I am telling, so this is A row, this is B row. Okay, now I am including vertical column, all the columns in formula. Okay, first column x, I cannot write x here, x is in which row? A. Okay, then I am adding one more column. Okay, dot, then x is in A. Okay, then this x is in B, this x in B. Now here, this column, two x's are there. One is 8th row and another is bth row. I am adding 2x. Okay, I am adding 2 row. Okay, so A plus B. Here also I am adding 2 row, A plus B. Now I have to minimize the expression. Okay, so you know A dot A is equal to A, right? So same term dot same term is equal to, you will get same term. From here also you will get same term. From here also you will get same term. From here also you will get same term, right? Now if you multiply A, B, A, okay, A, B, B, right? So you can say again A dot A, that will be A and remain B. Again A, B dot B will be B. So x plus x is equal to x. Okay, these are the properties. Okay, AB plus AB are AB. Now you can see in this expression I have written A and B. What are A? A is my first PI and B is also my second PI. And in this expression I can see I have two PIs. Okay, that means two PIs are all my essential prime implicant. Okay, now if I want to write in, so A is one essential prime implicant, B is also one essential prime implicant. So in my expression I have to include both A and B, both prime implicant I have to include. So A is what, if we remember, A is xz and B is yz. Okay, A means it was dash xz. Okay, it was, I suppose, a1 dash dash 1 and wz means dash dash 1 1 w dash 1 dash dash 1. Okay, so xz and wz, this is the Petri method. Okay, you have to include you have to write written all the you have to write all the mean terms in the form of the a b like this way, and by to write a formula by observing the chart. Okay, by particular column all have to add, right, but in column whatever values are there I have to check in this value which rows are present. Okay, so you have to include the name of the row here, and if you add two rows, then you have to put a plus sign, right? So this is the procedure for Petri method. Next I'll come to the one more process that is also related to KMap, but that is a different thing. Okay, map enter variable method, right? Map enter variable method. So where we can use this map enter variable method. Suppose you have one function A, B, C, D. Okay, one function is there, right? But you have to use, for realizing this function, for a minimization of this function, you have to use the three variable KMM. So if four variables are there, normally we used to use the four variable KMM. But if in the question it is mentioned like you have the four variable function, but you cannot use the four variable KMap. Okay, so for that you have to use the map enter variable. Or suppose you have the five variable, if you have a one function which includes the five variables, right? But you cannot know, you don't know about the how five variable KMap. Okay, so then you have to use the four variable. like this way. If you have the higher term of variables but you use the lower term of k-map, for that you need to use the map enter variable method. Okay, so I'll show you now how we can include map enter variable method. In map enter variable method, there is one procedure. In this procedure, for 6 variable and for 7 variable, I cannot use these processes. If we have the 5 variable, okay, or you have the 4 variable, if you have 5 variable and less than 5 variable, you can use this procedure. If you have the 5 variable and more than 5 variable, you have to use the different procedure for map enter method. So first procedure I will discuss. So you have the 4 variable, you have to use the 3 variable k-map for that, right? So if we have, so functions are 2, 3, 5, 4, 5, 13, 14. Okay, you have don't care also, 8, 9, 10, 11. Okay, so you have to use the 3 variable k-map. Okay, so first I am writing all the combinations here, right? Hmm. So all the the combinations I am writing here. Okay, 0, 0, 1, 1, like this way I am writing here. Okay, here I am writing for using the k-map, that will be easy if we write like this way. Okay, no, that will write like that. Okay, now I am writing the function. Okay, I am writing the function in which position I have those main terms, right? So it is m0 is not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 0 in m0 is not there, 0. Okay, m1 is also not there, m2. Okay, m3 is present, m4 is also present, m5 present. Okay, 6, 7, 8, 9, 10, 11, sorry, 8, 9. 8, 9, 10, 11, I have don't care. Okay, can I do 6, 0, 7 also 0, 8 don't care, 9 don't care, 10 don't care, 11 don't care, 12 0, 13 1, 15 1, 14 1, 15 also 0. Okay, so all the functions I have written here, meters I have written here. Now here it is a, b, c, d. So in 3 variable k-map, either you can use the ABC or you have to use the BCD. Okay, better if I use ABC. Okay, in 3 variable k-map. Okay, so where will be my D in 3 variable k-map? Okay, now the D will be used as a map enter variable. Okay, I have to reduce this 4 variable truth table into the 3 variable truth table. Okay, I have to reduce this 4 variable truth table into 3 variable truth table, because for drawing the 3 variable k-map I need the 3 variable truth table. Okay, right? So how can you reduce? So this, for this D will be used as a map enter below. Okay, this is the extra term. Okay, in 3 variable k-map, D is the extra term. D will be I'll put as a output. Okay, in 3 variable k-map, right? So for that, D should be compared with the F. Okay, and now you F dash, new F dash. Okay, new output, modify output. For writing the modify output, I have to compare the map enter value with the original output. Okay, because in 3 variable I should have only the 8 combination. 16 combinations are not there, right? So you can see I will compare these two with this one. Okay, you can see this, for these first two cases 0 0 both are same. Okay, so 0, these first two ABC are same, so I will compare these two values of D with the F. Now you can see here if my change D value, here it is 0, here it is 1. In both cases my F is 0 0, so my F dash will be 0. In both cases I can see my F is 0 0, that means my F dash will be 0 0. If I change D value also, my original output is not changed, so that means my modified output will be 0. Now in next two cases, these two are same. So again I compare this with this one. Okay, here also I can see if I change d value, but my f value is constant 1 1. Here it is also 1, here it is 1. In both cases my f value is constant, right? So it will be 1. Now come to third case. In third case also you can see 0 1 0 0 1 0. These two value I will compare with this one. Here also I can see for third and fourth these cases, these two cases, this is same 1. These two I am comparing. So for these cases, this is 0, 0. Now come to this one. Here also, for these two cases, don't care, don't care. If I change d value 0 and d value 1, for both cases, don't care, don't care. So x. Here also you can see x. Okay, now come to these two cases. 1 1 0 combinations. Okay, 1 1 1 1 0 combination. My d value is 0. Here, my d value is 1 here. So if I see the f value, here it is 0, here it is 1. Now you can see the d value is similar to the f value, or f value is similar to d. Okay, so both are same. Okay, so instead of writing this one, I can write d value. D value means here it is d. So f follows the d value. That's why I modify output. I have written the f as a d. Okay, that means I am comparing this value and this value. I am putting modify output. Okay. So in the last two cases, 1 1 1 1. Okay, in last two cases again you can see if my d is 0, f is 1. If my d is 1, f is 0. That means it follow in inverting operation is there. Okay, f follows the inversion of the d. Okay, so it is d prime. Okay, now your f dash will be d prime. Now you can see here you can see only 8 outputs, and if you write this thing, if you remove d1, you can see 8 input combinations are there. Okay, now I am drawing the KML. Okay, A, B, C. So first is the 0 0 1 0 0 0 1 1 1 1 0. So I am considering this is 0. Okay, 0 1 2 3 4 5 6 7, right? So 0 0 0 in 0 means 0 0 0. Okay, here my f dash is, here I am drawing the f dash. F dash is 0. Okay, in 0 0 1 my f dash is 1. Okay, 1, right? In 0 1 0 1, 0 1 1 it is 0. Okay, 1 0 0 1 0 0 x, 1 0 1 1 0 1 x. So 1 0 1 x. Okay, 1 1 0 1 1 0 is d prime. 1 1 0 is d prime, and 1 1 1 1 1 1 is d. Okay, now you can see you can after that what is the procedure? You have to do the grouping, then after that you have to write the expression from the grouping. But when you do the grouping, you can do grouping, but you cannot write the expression because these are x and these are d and d prime. You cannot write the expression. How can you write? Okay, if all ones are and some x are there, so from that you can write down the expression. Okay, so after that, after doing this, the original K-map I have drawn. Okay, after that you have to divide the K-map based on some conditions. Okay, I'm removing this one. And after that you have to reduce the K-map based on some conditions. Okay, you will get 3 K-map. Okay, the first condition. In first condition, my d and d prime both should be 0. Okay, so by considering d and d prime as a 0, I will draw the K-map. B, C, 0 0 0 1 1 1 1 0 0 1. Okay, 0 1 2 3 4 5 6 7. Okay, so if my d and d prime are 0, then I will not consider these two same, right? Okay, these are 0. So 0, that means I will not consider. Now I am writing the expression from this K-map. Okay, first you have to do the grouping. Okay, this one and x can create one group, this individual one can create a one group. Okay, so I am writing the expression. From writing for choosing this group, these two values are constant, b and c. For this one, a prime, b, c prime. Okay, this is suppose f1 dash. Okay, now the second case. In the second case, what I have to do, I am first drawing the camel. This will be f2 dash. Okay, so here it will be first in this case, in the second case. In the second case, what to do? I am putting d prime 0 and d 1, and all other 1 should be considered as a x. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay, here in this case, one d prime should be 0 and d is 1. Okay, so for this case, this condition I have to consider along with this other one. So other one, here it is 1 also, and here it is also 1. This one will be replaced by the x. Okay, so I am putting x here, here also x. These two x are remain same. D prime is 0, it is 0, and d is 1. Okay, d is 1. Now to write the expression, this will be f2 dash. Okay, so here first writing expression I have to include first d. D is 1, that's why I have to include d here. Then I have to write the expression from the kmap. Okay, d that should be multiplied with that particular expression, the whatever expression I will get from this kmap. Okay, so this 1 and x can create a one pair. I will not consider other x. Okay, why I am replacing this other one as x? Because this one I have already considered in this expression. Okay, that's why this one are not required. So that's why I am replacing these two ones are with the x. Okay, so d I am considering 1 and here, and that's why I have to include d here. D and multiply the expression. Okay, this expression is c. C. Okay, DC. Now come to the fourth one. In fourth one, sorry, in third kmap, so d prime is 1 and d is 0. Okay, I am drawing the kmap here. A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, the same condition. With consideration of this one also, the other x 1 should be replaced with x, and d prime 1 and d is 0. Okay, opposite to this condition, right? So here other x 1 should be replaced by x, x and x remains same. D prime is 1 and d is 0. Okay, now these two can create one pair, or these two can create one pair. Okay, so what will be the expression? This is f3 dash. F3 dash, here I have to include d prime because d prime I am considering here, right? So d prime and then multiply the expression. This is a. Okay, a, and from here it will come c prime, a c prime, right? So now my final expression will be like this, addition of these three expressions. Okay, so final expression will be f dash, it will be bc plus a prime bc prime plus dc plus d prime a c prime. Okay, so by using the 3 variable kmap I can get the 4 variable expression without using the 4 variable kmap, right? So this about the 4 variable kmap, and there is one procedure for you can use the 4 variable map enter variable kmap that I will discuss on the next class. So kindly subscribe my channel and like and share.